Physics at home, activity on the coefficient of restitution. Okay, the first thing you want to do is to assemble your meter tape. And you're going to need scissors and tape. I prefer kind of Scotch tape or something transparent. But we're going to take our flat 8.5 by 11 sheet of paper and cut out each of the 4 meter stick segments, and they're by 25 centimeters. And just be careful here when you're assembling those together. Just note that you want to, I cut the edge of this second piece, the 25 to 50 tape, I cut to the edge, and I left the 0 to 25 all the way out, so that way I would have some room to overlap that 25 centimeter line. Okay, so we want to make sure we're exact as we can be, and do that obviously for the other 2 pieces as well. And if you see right here, I measured it right from the floor and taped it right to my this door here, 1 meter. And I was able to try to get 0 right on the edge, right at the ground. And we want to make sure we're bouncing off of a hard surface. So I didn't use my rug here or carpet. You want to make sure you use tile or wood floor, or if you're in a garage, like concrete surface would be great. Okay, there you go. On to data collection. Collecting your data. Each of you will be dropping your ball from an initial height of 1 meter. As you can see here to the right in my video, the ball will be right above that 1 meter mark on my meter tape. It looks a little higher right now, but that's because my iPad was a bit tilted. So, as you look through here, as you observe the rebound height in centimeters along the tape, be sure to convert it to meters by dividing by 100, or just moving the decimal place over 2 places. Let's observe one of these drops here for a moment. And if I drop it, there you go. And I want to observe the height that it rebounds back up to, right? So if I can just pause it, hit the pause button right there. So we're slow-moing. There it goes. And there. It's hard to really pause this, everybody. Oh, that was really good right there, wasn't it? Oh, maybe there. All right, let's say that's roughly where it bounced back up to. So you want to make sure you do the reading of where the bottom of the ball right there rebounds back up to. And I took that to be, for the first one, it was about 48 centimeters. So in meters, that's 0.48 meters, okay? And if we look at the successive drops here, so that was my drop number 1. There's drop 2. And I believe that was actually about 49 centimeters, or 0.49. And the last drop there was about 47. So converting to meters was 0.47 meters. Now I want to take the average of those 3 measurements. So I would obviously take 0.48 plus 0.49 plus 0.47, and then divide their sum by 3. This is easy to do because the average is clearly 0.48 meters. And that's what we'll use for the average for the first bounce height as we calculate our potential energies. Now that we have our data, it's time to do our calculations. So for the initial potential energy at 1 meter mark, we're going to take our mass of our field hockey ball that I had, which was 0.163 kilograms, times g, or 9.8 meters per second squared, times the initial height of 1 meter. So if I quickly just roll that out on my calculator, it's 0.163 times 9.8 times 1, and that gives me an initial PE of 1.60 joules. Now for the first bounce height, the same thing, 0.163 kilograms for our mass. Acceleration due to gravity is still 9.8. But now if you remember, my average rebound height was 0.48 meters. So I want to calculate what that PE is. So 0.163 times 9.8 times, oh, hold on, I typed that in wrong, everybody. Not that you saw that. 0.163 times 9.8 times 0.48, and I get a potential energy at the first bounce of 0.60 joules. And I'm just rounding to 2 decimal places. So the question is, how much energy was lost on the bounce? So that's where I come up here, and I'm going to take the 1.6 joules initially that I had. That's the total energy I had to begin with. And now I only have 0.77 joules left to find out how much energy I lost on the bounce. So 1.6 minus 0.77, and that gives me 0.83 joules. So that's how much energy the field hockey ball lost due to the bounce when it hit the ground. But we want to compare the energy lost for a variety of balls, like tennis ball, field hockey ball, basketball, etc. So for an accurate comparison, we want to calculate the percent lost. Otherwise, the field hockey ball had 1.6 joules, it lost 0.77, but what percentage is this of the initial energy? It looks to be about 50%, right? 0.83 and 1.6, but let's do it out just to be sure. So the energy loss, so that would be the energy loss, or 0.83 joules, and I had 1.6 joules to begin with. So if I divide that out, I get 0.52 basically, right? Which really tells us that's 52% energy lost. The coefficient of restitution. It's a measure of an object's bounciness, and the COR value can be between 1 and 0. Thus, if the COR is close to 1, it's very bouncy. If the COR is close to 0, it's less bouncy. And we can calculate that right here by taking the square root of the bounce height divided by the drop height. So let's put in my numbers for that field hockey ball there. So it's going to be the square root for me. That average bounce height was 0.48 meters, and I dropped it from 1 meter. And so if I do that square root out, I will get 0.692 for my coefficient of restitution. And it's pretty close to 1. That field hockey ball was actually pretty bouncy on that wood floor. So that is how we do our calculations. Be sure to enter all that information on the Google form link. And thank you for watching, and see you in class.